Good morning, students. From last two sections, we are discussing about the applications of uniform circular motion. Today, we are discuss about the third application, which is nothing but a vehicle on the bank road. What is bank road? What is the angle of banking? What is banking of road? First of all, we see the definition of banking of road. What is banking of road? When we going along the curved road, then the layout of the road is such that the inner edge and the outer edge are not parallel, but the outer edge is elevated by some height with respect to the horizontal level. Such layout of the road is called as the banking of road. And what is the angle of banking? Angle of banking is denoted by theta. The angle made by this horizontal level with the road level, it is called as the angle of banking. In this section, we are discussing about the third application, that is vehicle on the bank road. But for that, we are going to discuss the first application, that is the when a vehicle is traveling along a plain road. What happens on the plain road? A friction is the most important factor when a vehicle is traveling along the plain road. But we cannot rely on this friction because in the rainy days when rain fall on the road, the layer of the water decreases the friction between the tire and the road surface. Therefore, the value of maximum velocity also decreases, and the other factors also reduce the friction between the tires and the roads. Therefore, we cannot rely on the friction. Therefore, to overcome this, for this reason, layout of the road is such that the outer edge is elevated by some height with the inner edge. It is called as the banking of road. Consider a vehicle. Consider a vehicle is running on a curved road as shown in the diagram. Let us consider that the mass of the vehicle is equal to m. And we all know that the mass of the body is equal to m. Then the weight of the body is directed in the downward direction. Therefore, what is the weight of the body? The weight of the body W is equal to mg, which is acted in the downward direction. Now, here one thing should be remembered, that the frictional forces we cannot take into the account because this equation is derived only for the normal forces and the weight of the body. Therefore, according to the Newton's third law, an equal and opposite reaction is acted upon a vehicle. This reaction is called as the normal reaction. Now, this normal reaction is divided into two components, rectangular components, n cos theta and n sin theta. This n cos theta is in the upward direction, exactly opposite to the weight of the body, and the n sin theta is in the horizontal direction towards the center of the circular path. Therefore, if we calculate the balancing condition, then we get this weight of the body or weight of the vehicle is balanced by the n cos theta. Therefore, we can write this n cos theta is equal to mg, and this n sin theta is directed towards the center of the circular path, and we all know the force which is always directed towards the center of the circular path is a centripetal force. Therefore, we can write this n sin theta is equal to mv square divided by r. What is r? R is the radius of the circular path on which this vehicle is running. Therefore, if we divide equation 2 by 1, then we get n sin theta divided by n cos theta is equal to, it is mv square divided by r, it is divided by mg. Therefore, this n get cancelled and sin theta upon cos theta is equal to tan theta. This tan theta is equal to v square divided by rg. Therefore, we can write this V square is equal to Rg tan theta, or V is equal to under root Rg tan theta. This speed is called as the safe speed of the vehicle, with which a vehicle can safely driven along a curved road having the radius r and the angle of banking theta. Okay, now from this equation we can calculate the angle of banking also. How we can calculate angle of banking? From this equation we can write theta is equal to tan inverse of V square divided by Rg. So in today's lecture, we are discuss about the third application of the uniform circular motion, that is vehicle is running on the bank road. In this case, we consider a vehicle which is moving along a car road. The weight of the body we know always directed in the downward direction, and this weight is balanced by the component n cos theta, and another component n sin theta is directed towards the center of the circular path. And from this conditions we derive this equation V is equal to Rg tan theta, and theta is equal to tan inverse of V square upon Rg. Okay, today we discuss about this application, but this application is also applicable. We stated earlier that this equation is only when the frictional force is absent, but if the frictional force arises, then what happens? This equation get changes. In the next section, in the next lecture, we are discuss about that application when frictional force we taken into account. Okay, thank you. Have a good day.